Now we're going to talk a little bit more specifically about the actual technologies behind the double take availability product, and we'll see how those same technologies are applicable to the other products as well. First, we're going to talk about data protection and failover. And with data protection and failover, well, that yellow arrow is going to represent, again, that double take replication that we talked about at the very beginning. And the blue monitoring and failover arrow is representing that failover monitor that the target's running to check the source server's health and make sure that everything's working. In this case, in this example, we just have a basic file server with file shares. Users are connecting up to their file shares, accessing their data, uploading files, downloading files, etc. Everything's working normal. Should you lose that source server, what's actually going to happen is the target failover monitor is going to recognize that condition and initiate the failover process. And you can do any number of things through that failover process. It is customizable and configurable. In this case, one of the examples is to have it start services, specific services that you need started on the target side at failover. And the other thing I'm going to point out here is a basic concept that's going to apply to the other technologies as well. When you fail over, when that target assumes the source server's identity, you have two choices on how you perform that failover, how you have users reconnect to the failover target without realizing actually that anything happened. The first is through IP address and name takeover. And in that case, the target is going to assume the source server's IP address, and it's going to begin representing that IP address on the network. So users will automatically connect to that IP address because that was the source's IP address, and they won't realize that anything has happened. They'll automatically be redirected by the network subsystem. The other way to perform failover, the other failover type, is through DNS redirection. And with DNS redirection, what actually happens is that part of the failover process has the target server updating the DNS server to modify the source server's records to now point to the target server's IP address instead. So then in that case, users are seamlessly redirected through the DNS subsystem. So either way, after failover, users connect up to the target server that's failed over and acting as the source server, and they're able to access their data because that's provided for them through that real-time replication. The data is there, it's up to the moment, up to the time of the source failure, and that data is available to them. That's a very simple model. That's our data protection and failover. The next one we're going to talk about is our full server protection and failover. And as you can see at the very bottom of that, we're still protecting the data just as we did in the previous one. The difference here is that now in addition to the data itself, we're also going to protect the source server system state. When we talk about the system state, we're talking about the program files, the binaries, the registry information, any of the logical identification of that source server minus the hardware specific information. So we're going to replicate that system state to a staging directory on the target server. And in this example, we see on the left-hand side is our source is a BlackBerry server with all the data and functionality installed on one server. The target server in this case, for the full server protection and failover, the target server is just a basic Windows server with the double take software installed. The target is going to be monitoring the source, and again, we're using real-time replication to protect both the system state as well as all the data from the source. Should you have a source failure, what's actually going to happen is on the target, we're going to take that replicated system state from the source and we're going to apply it to the target system state. And we're going to merge that source system state into the target system state and reboot that target server. Once it's rebooted, it's going to come up and it's going to logically be identical to the source server. Again, all the identity, the SID, the GUID, anything non-hardware on the target system state is going to be overwritten. And so that target is going to come up with the full functionality and all of the data that the source had because that's been protected, again, using real-time replication. The same two choices, you have same two choices for failover type with the full server protection, whether you want the target to assume the source server's IP address, and that's really going to make sense if you're on the same IP subnet, or if you want to have the DNS redirection that I already talked about. And that's going to make more sense when your target is in a different IP subnet than the source. You're going to need to use the DNS redirection. The last type of protection and failover we're going to talk about is our virtual recovery assistant. And here, this first slide really introduces the concept of the helper VM. So as we talked about earlier with double take replication, we're replicating, typically it's a Windows-based file system, and we're replicating that to the target side. It's also going to have a Windows-based file system so that we can apply those changes and keep that target replica concurrent with the source. Well, in the case where the target is an actual virtual host, like a VMware virtual host, obviously with the VMware, you're not going to have that Windows file system. So what we actually have you do is create a virtual machine, a helper VM, or an appliance, you might call it. We have you create that on the target side, and that helper VM is just going to have a basic Windows OS installed and the double take software installed. With that helper VM, what you're actually going to do is set that up to be the replication target for any source server that you want to protect. Additionally, that helper VM is also going to perform the failover monitoring functionality that we discussed earlier. So with that helper VM concept, you're going to be able to protect multiple source servers. It doesn't matter whether the source server is a physical or virtual machine. All that matters is that the target is a virtual host and can host this helper VM to act as the replication target. So you can have multiple source servers. The general rule of thumb is up to 10-to-1 protection using this scheme. That's going to vary depending on a lot of different variables, on how much load, how much replication traffic, etc. But a good rule of thumb is a 10-to-1 protection. You can also load balance and have multiple helper VMs on the same virtual host and be able to perform that way. A couple other things that I'll mention that, also with the Hyper-V, if your target is a Hyper-V virtual host, obviously that is a Windows OS and a Windows file system, so you do not need a separate distinct helper VM. The host itself can perform that helper VM functionality. So once you have your helper VM set up, you can go ahead and protect a source server. And what's actually going to happen in that case where you're protecting a source server is that the helper VM is going to create a virtual disk, a VMDK for VMware or a VHD for Hyper-V. But the helper VM will create a virtual disk that corresponds to each logical volume, each source logical volume. So in the example that we see here, we have a C drive and a D drive. So that helper VM is going to create 2 virtual disks, and it's also going to create a VM definition file that's going to remain dormant during just regular protection. So as data changes happen on the source, those changes are replicated over to the target. They're sent to that helper VM, and the helper VM is going to apply those replication changes to the virtual disks it owns that are associated with that source. Should you have a source failure, what's actually going to happen is the helper VM will recognize that because it has a failover monitor that's watching the source server for just such an event. But the helper VM is going to hot swap away those virtual disks that it owns that correspond to that source. It'll hot swap those virtual disks away, attach them to the dormant VM definition file, and spin up that fully formed VM. So when the failover process is finished, you'll have that fully formed VM that's going to contain all the data, all the functionality, because again, with this scheme, we're also protecting the system state from the source. So we're going to have all the necessary information to represent that source, and you'll have all the data updated real time through double take replication. This is supported, this VRA, this Virtual Recovery Assistant Protection and Failover, is supported for both Hyper-V and ESX and ESXi virtual hosts. So that's a basic overview of the 3 availability styles of protection. Now we're going to talk a little bit about the Recover Now offerings also for protection and recovery as opposed to failover. With the Recover Now product, the difference here, and you can kind of see on the left-hand side, the difference here with regular availability is with Recover Now we have your target is actually going to be what we call a repository server. And that repository server can be the target, the replication target for multiple source machines. You can choose to protect only the data for those source machines, or you can choose to protect the entire server. So we're talking about, again, the data and the system state for those source machines. Once you've set up protection, you're going to have the same double take replication. So you're maintaining a live data set. You're maintaining a live copy, a replica for each source that you're protecting. But now what's different about the Recover Now product is that we offer you the ability to do object level recovery. And this is offered through our CDP or continuous data protection functionality. With that, what actually happens is once you establish that target replica on the repository server, the changes that are applied through replication, those are actually journaled real time so that as those changes are applied, we give you the ability to roll back to a point in time before those changes were applied. And where this really comes in handy is that if somebody deletes a file or a folder, a user deletes a file or a folder, this is going to give you the ability to recover that specific object as opposed to recovering the entire data set to get that object. So if you do need to perform that object level recovery, you'll actually use the Recover Now console to create a virtualized view of that data set to allow you to kind of drill in and recover that specific object. Again, it could be an entire volume, a folder, or just an individual file or multiple files if you choose. Once you create that virtualized view, you're going to be able to recover that data. You can recover it back to the original server. You can recover it to an entirely new location. And then one other thing I'll mention there is that in addition, if you have Microsoft Exchange is a server that you're protecting, we have an add-on for Microsoft Exchange that allows you to do object level recovery that's Exchange specific. So we're talking about mailbox databases, mailboxes, or individual emails themselves can be recovered using the same concept. So that's our object level recovery with Recover Now. For the data protection that we talked about originally in the availability product, the Recover Now gives you the ability to do data recovery. So if you only want to recover the data for a specific server, you can do that. You can do object level recovery. Also with the Recover Now product, we offer you the full server recovery. And this is going to operate the exact same way that we talked about with the availability product. The difference here is that you're performing that recovery from the repository server, and you're going to point to that recovery server, and the recovery server is just going to have a basic Windows OS, and once you are through pushing the data and the system state to that recovery server, when it reboots, it's going to come up again identical to the source that it was protecting, and because you've got all the data and all the functionality protected through real-time replication. Whether you recover back to the original source or into an entirely new physical or virtual server, doesn't matter. And then finally, with the Recover Now product, you also have access to the VRA technology. And here with the repository server, you're going to recover to a virtual host, and this technology allows you to provision that virtual machine that you're recovering to on the fly. Once the synchronization process is done, once you've pushed the data from the repository server to the helper VM, it's going to detach those virtual disks, again the same process, attach them to the dormant VM definition file, and spin up that fully recovered source server. It's going to come up identical to the source before it failed. So those are our three basic offerings in terms of protection styles. You have data protection, full server protection, and then virtual recovery assistant or VRA protection. And those three styles are going to apply to both the availability product as well as the Recover Now product. It's just the differences with the availability product, you're looking at low RTOs, you're protecting your tier 1 servers, and you're looking at very low RTO times. With the Recover Now product, you do not have the failover functionality. You're looking at higher RTOs, but in addition to the same three styles, you also have access to that object level recovery through the CDP technology. And that's all we have for today. I'd like to say thank you for sitting through the presentation and learn more about our Double Take products through Vision Solutions. If you have any further questions that you'd like to ask or follow up, feel free to use the contact information included, and we'll talk to you later. Thank you very much and have a good day.